Saran sir, please share resource person profile, sir. Thank you, sir. Good afternoon to one and all present here. I welcome all the participants to this fourth day short-term training program on nanotechnology and functional materials phase 2. Now we are going to start this fourth day second session. Once again, I thank all the participants for joining with us. Now let me introduce our eminent resource person, Dr. K.R. Aranganayakam, Assistant Professor, Head Department of Chemistry, Kumaravaru College of Technology, Coimbatore, Tamil Nadu. He is having a total 12 years of teaching and research experience. His areas of research interest are synthesis of nanomaterials, heterogeneous catalysis, environmental applications and organic transformations, magnetic materials, analytical chemistry, solid state and inorganic chemistry, chemistry of advanced materials, computational chemistry, nanocarriers for drug delivery system. He has published more than 22 research articles in international peer-reviewed journals and 2 books from Nova Publishers, USA, and Lampert Publishers from Europe. He has presented more than 52 research papers in national and international conferences. He is being an editor in several journals published from elsewhere, which includes World Scientific Journal. We are honored with your presence, sir. I request our resource person to proceed with the sessions. Requesting, sir.
Great. Thank you, Professor Madhivanan, sir. It's my immense. It is audible, sir?
Yes, sir. Yes, sir. Please, sir. Please proceed, sir.
Yeah. It's my immense pleasure to be part of this AICP phase 2 short-term training program on nanotechnology and functional materials, which is organized by the Department of Mechanical SV College of Engineering, Tirupati. And also, I must thank to the organizers and management for giving me this opportunity to share my views about nanoscale research. So let me share my slides, and I have prepared few slides for you. And let me start sharing my screen. Is my screen, sir, visible, sir?
Yes, sir. It is coming, sir. Yes, sir. It's visible, sir. Yes, sir.
Yeah.
Yes, sir. Perfect, sir. Now it is visible. Sir, again. Yes, sir. Yes, sir.
Is it visible, sir? Yeah.
Yes, sir. Perfect, sir. Please.
Yeah. Thank you once again to the organizers and management for giving me this opportunity to share my views about nanoscale research scope and opportunities. Even the organizing team is from mechanical engineering, but I am basically a chemist and I am a basic science researcher, and I'm working in the field of materials chemistry and materials science and new material development, and also few drug designing applications as well as we have some creative research. And before my presentation, and I would like to share a few pieces. The presentation is quite different from the normal ones. And also, this COVID-19 situations has changed the entire lifestyle, especially in education sector. So the present situation, I hope everyone are being safe and everyone are being taken care of. Your family, please. I hope everyone are stay safe and staying healthy. And please, this is a very tough time for all mentally as class physically, and have a mindset to go to meet this kind of transformation. And also, I kindly we ensure that to engage yourself in this positive way. What I personally believe is, if we personally okay, and definitely we can able to take care of our family also. So if both those family care, family are okay, and definitely we can transform many things. We can do wonders in the field of education sectors. The one before. And so we need to support them, and we need to take it positively to transform these things. So this education transformation, it is most important nowadays, and we stay skilled. That is most important thing for the survival and to face the upcoming issues. And let me start with my presentation. And this is today, I'm going to talk about some of the nanoscale research and scope and opportunities. And just before that, just I would like to consolidate my content of my presentation. And first, initially, I will go with some kind of basic fundamentals. And after that, how can we prepare the nanomaterials with our available facilities? So this is very easy. While usually people, they are purchasing some kind of nanomaterials and they are using for their own applications. And instead that we can prepare very easily. So we need to bridge the science and engineering and other aspects too. And also, and I would like to share a few slides about my research contributions, and also what are all the possible research areas for the to face the upcoming issues. So this while moving to this my presentation, knowingly or unknowingly, we are moving towards recent technologies. So I do not know who created this picture. This is the human revolutionary stages, and where we started. But at the end of the picture, the person is sitting in front of computer. This is the reality what we are doing right now. So during this period, we have transformed many ways to by adopting the technologies, irrespective of the generation and irrespective of the age groups and irrespective of the cadres, and we have moved towards the recent technology. So previously, we have used this kind of televisions in this case. But nowadays, we have moved towards the LCD and LED monitors. So there are many transformation, revolutionary changes has been done in the electronic industries. So there are, what I personally feel is there are three factors which are involved in this kind of transformationary change. The one is design and the coding, and the second one is the material used to develop these kind of new materials, and the third one is the processing. And these three factors which involves to produce a new material development. And also, after that, the LED development of the electronic industries, and people, they started developing right now the flexible electronic systems. This is a television. I hope everybody's seen these things. This is the one, and we can use this flexible electronic material applications. This is a 360-degree view of this television. And also, one more picture depicts that we are moving towards the recent technology. Previously, we have used this kind of mobile phones, like brick-like mobile phones we have used. And also, we have invested many costs to buy all these things. But nowadays, the entire world is in our hand. Now we are using the smart mobile phones with the compact size with the high configurations. Nowadays, people, they are also not using some kind of laptops and desktops more. But even in mobile phone itself, we have many kind of technologies are embedded. So this is also silently indicates that that we are moving towards the recent technology. So and also one more picture showing that previously we used to buy the magazines and articles in shops, and we used to read this kind of habits. But nowadays, everything we are using with the tabs. And I do not know these persons in our family, all they are using reading newspapers, but everyone is using the recent technology, mobile phones and laptops. So what it indicates that we are, again, it confirms there is some revolutionary change has been happened in the communication sectors also. So there are, in which also there are some coding development is also there, and there are some materials they have developed for like chips and flexible boards and thin film technologies has been implemented for designing the touch screen options, and also some of the processing has been changed. So this depicts that we are moving towards the recent technology. And also, this is the picture, and that is we are one more time it depicts that we are moving towards recent technology. Panasonic is a brand who developed a memory storage devices. There they have used low capacity of memory storage solid state materials to store the data. And initially, they have used for 8 MB. They have prepared and they have supplied for about 8 MB. And later on, they have developed an 8 GB and multiples of storage capacity increase. So there, they have used some magnetic materials to store the data. And also, they have, without altering the designs and without altering the size of the material, and they have increased the capacity of storage. So what it implies is, so which means that there are many revolutionary changes has been happened all over India in different sectors, including pharmaceutical sectors, electronics and communication sectors, and also in this kind of memory storage devices also. And this is the factor which there are many materials where material innovation is played a major role in all the industrial areas. So we need to concentrate on that material aspects. So this is one more picture from the automobile sectors, automobile and mechanical systems. And previously we have used the first picture. It is the first developed bicycle, and the last picture depicts that it is a bicycle. It is a movable and adjustable also. So this is the material. It is a lightweight material, and it is a flexible material, and it will not break out any times. So there is some transformation has been happened. This is because of new material innovations. So as a material chemist, what I personally believe that there is any kind of industry if the material plays a big role in developing a new products. So this is the consolidated slides. What I feel is this is, and we have used some kind of technologies, what we are calling as existing technologies. Now we are using some kind of technologies that this will give a very big way of the very big scopes to do many kind of research as well as usages of products also. So the future technology is obviously it is a nanotechnology. So everywhere the people they were talking about nanotechnology, but the nanotechnology and nanomaterials or nanoparticles, the word nano that is that has a power. That nano called it was started. It is coined by the Richard Feynman in the year of 1959. That we will see it later. And who wants this kind of nanotechnology? Whether this nanotechnology it is purely for physicist or material science or a chemist. No, nanotechnology it is an interdisciplinary approach. Nobody take an ownership for mobile phones because there is some communication is there, and coding there is electronics and communication people are there, and battery energy storage device. There is batteries are there. There the chemistry plays a role, and electrical engineering plays a role. And also coding that the computer science and computer clustering, the derived branches are supporting that, and the thin film technologies are there to operate the touchscreen options, and this which indicates that even if you are taking a mobile phone and nobody take an ownership. So it is an interdisciplinary approach. When the interdisciplinary approach comes, then only the product will arrive to the market. And if you take an two-wheelers or cars or bikes, whatever it may be, there are many components are there. The contribution from many sides, contribution from the many domain-specific areas were involved in that. So they have what I personally believe the single domain area will not be give a success rate to develop a new product. But when it comes to an interdisciplinary approach, definitely we can do wonders. So the nanotech, what I feel also that is nanotechnology created an opportunity to collaborate with other engineers also. So to the future, when we are developing a product, definitely it will be an interdisciplinary approach. This will help us to connect each other. So this here I have presented some of the books which are very useful to learn about nanomaterials and nanoscience and nanotechnology. And there are many other books and internet sources are also available. I have read and I have gone through all these books. This was really wonderful. And really it is used to learn about the fundamentals also, and also in the specific areas. There are many recent technologies are also reported in these books. So Nanoscience and Nanotechnology, Fundamentals to Frontiers by Ramachandra Rao sir and Wiley, publisher Wiley Interscience, and also the Nanoparticles for Biomedical Applications Elsevier, and the Nanoelectronics Wiley, again one more Wiley, and Nanotechnology for the Energy Challenges, and Nanotechnology, a big idea. This is a consolidated book, and you can read, definitely it will be a very nice book to read all these things for a longer period. So nanomaterials for energy, environmental, and engineering applications, all together, and published by Wiley Science. Right, the nanotechnology, how it started. Whenever you are listening these kind of nanomaterial-based lectures, definitely you will see the man who is that is called the Richard Feynman. And without addressing his point, no one will carry out this kind of lectures. So, by the way, in line with the senior professor's line, but the idea, the word nano coined by the Richard Feynman, there are plenty of rooms at the bottom. This is the famous sentences. And the Richard Feynman at the American Physical Society meeting at the California Institute, he was coined the word called nano in the month of December 1959. Just to think about the years what we are right now. So we are in the 2020, almost 60 years has been gone. So after 60 years long back, now we are talking about nanotechnology is a recent technology. So this point comes to my mind, and I started with searching. Before that, is there any other nano-based products or nanotechnology were used by the scientists? So the Richard Feynman, and they have some definitions of nanoscience and nanotechnology. So the word nano, it is derived from the Greek word that is called nanos, and the phenomena and manipulation of materials at the atomic and molecular level. And we are developing a material, and we are studying the characteristic properties that is alone. If we stop, that is called a nanoscience. And if we are using that kind of material to the real-time applications, we are converting into the product. So that a conversion of this nanoscience into the real-time product, that is called nanotechnology. So people nowadays, there is some problem in differentiating these two. And the people always there, I am a nanotechnologist. If I have developed some kind of product for the real-time applications, then only I can call it as nanotechnologist. But as of my side, I am a nanoscientist. I am a nanoscience man. And also the particle size, when it comes to 1 to 100 nanometers, that is called nanomaterials. So my definition about nanoscience and nanotechnology is we can making big things from small stuffs. So this is all about my definition with the 7-letter word. So when after the Richard Feynman coined the word, and just I crossed that it is started in the year of 1960s, but later on the studies are indicating that the 100 years ago it was a known art, and there are different colors of pattern painting materials they have used. All these colors are made up of gold. So this was identified 100 years ago. Right. So recently, the scientific approaches and scientific peoples, they have started developing a new nanomaterials with the support of gold and silver nanoparticles. And if they have reduced the size, they are seeing the different colors was observed. So which indicates previously they have used the blue colors. So here also some blue colors are also there, and also yellow, red, and blue. So some of the combinations. At the 100 years ago, people, they have used this kind of technology, but they do not know what is nanotechnology. So this is the one point that is previously the people, they have started working on this. And also some of the nanotechnologists in ancient times, during the war periods, and the Damascus steel they have used as a sword. And there you have seen the material with the combination with the carbon material. They have added some composite material. They have created some composite materials with the support of carbon nanoparticles, and they have developed a sword, and it is a high strength. And also here you can see some pictures, the sword which is developed with the support of copper nanoparticle based things. So recently the people, they have reported that all these things are based on copper nanoparticles. And also our ancient times, Indian times, the people, they have used busmas, right? So busmas in the sense of it is any materials if you decompose at higher temperatures, and finally it becomes an activated carbon. And if you process that activated carbon, then it makes to graphite, and finally it end up with this graphene oxides or some kind of any other materials based on the composition of the source material. So there they have used as a busmas to treat the many diseases. So here there are four people are there. Tirunjana Sambandar, Tirunavakarasar, Sundar, and Manikavasana. All these people, they have used the busmas, and they have done wonders to treat many diseases. Also, one more picture. Then I realized that the people, it was not nanotechnology. It was not started in the year of 1960. It was started in ancient times onwards. So ancient times, and also Sri Bohar. This is a famous South India temple. Once, if anybody visited South India, please do visit this temple for Lord Muruga, and which is located at Palani. And Sri Bohar, who developed a Nava Bhashan statue, the statue for Lord Muruga. And Nava, in the sense, it is called Nayan. So it is not 10 power minus 9, but he developed some kind of Nayan. It is a combination of 9 materials. So what my perception about this picture is, any one or two materials are combined together, and it produces a new kind of material that is called a composite material, or else simply it is called a nanomaterial. So there are 4 or 5 metals are combined each other, and we are producing that is only called composites. So Bohar, who developed a composite materials at the time, so the lifetime and the durability and the properties and the number of medicinal applications are there in this statue, and they will coat sandals or basmas on the statues, and they will take that basmas and they will eat it, and all the diseases will get cured. There are many medicinal plants are there. So medicinal applications are there. Sorry. So there, Sri Bohar, who developed nanocomposite materials in the ancient time. So I was thinking that who is the father of nanotechnology? So it was scientifically it was coined by 1960s, 59, and when we go back, and the ancient Indians or they do not know what is nanotechnology, but they have used some kind of nano-based works. And also at the time, who gave some guidelines to them to create that kind of nanocomposites and development of new materials. So at that time, I was thinking that why not we will search for some kind of things. There are many natural materials out there. So it is available in the internet itself. Everything it was collected from the internet. So the structural hierarchy of geco-adhesive systems, they have scanned all the ecosystems, and the arrays of the statues was picture here CDE, and it is it's a orderly arranged patterns was observed. It is in this nano size. So there it is a small architecture, and it is started from the small one to the big one, and it was ordered perfectly. So it works in these things. So it is the natural nanomaterial mechanism as well. So, and also we can see the butterflies, and if we take the butterfly, some specific portion, if you scan it, and definitely the researches has been done already. So there are, after that, they have seen the photonic crystal structure, crystal structure like structure was observed in this butterfly. So what it indicates that previously God created many things. God played a wide role in vital role in this kind of new material developments. Now we are collecting and we are mimicking the existing one, I think, right? So, later on, the people they have started searching with this kind of nanomaterial systems. Now, the photonic crystals based structures it is used in the many of the electronic applications. Similarly, in the field of the natural nanomaterials example and lotus leaves, and it is an strongly believe that it is a water repellent material. So the textile and fashion technology researchers they are creating a new fabric or shorts pants with a hydrophobic nature. If any dust on this on the shirts or pant, just flip it off and definitely all the particles will go away. So this kind of nano material systems and nano coatings was already observed in the natural systems also. And where the lotus leaf was scanned, and finally they have identified that this is a nanostructure architectures was observed in this kind of lotus leaves. Similarly in bone marrows, right? So what I feel is that we are making the question arises from my side is we are making an attempt to mimic the wonder of nanoscience in nature. Yeah, exactly. Obviously, if we wanted to develop any kind of material, there is no need for literature surveys. That is also required. I will not deny that fact. But we need to look at the nature, enjoy the natures and the species around us. And there are nowadays the species, living species, or the rate is very less, getting down. But if we look at all the species and if we observe all the things, and definitely we will get some idea, and then we will start doing researches on that particular area. So Gecko is a best example for the adhesive feeds. So we will take this kind of adhesive systems, and they are making these kind of wall floor hangers was developed with the help of silicon-based materials. It was the source is the Gecko, and also the self-cleaning light reflecting butterflies. There are different colors of butterflies are we have seen during our period, and in which if any dust or any other what it is a best water repellent, and also a self-cleaning material. Once if it is the butterfly flipped the wings, and definitely there are no particles on the surface. So it is also it will be glitter on night and in daytime, and some kind of photonic crystal structure was observed, right? So we can see if we see this kind of structures, and if we go back and we will search what kind of material architectures are there in this butterfly feathers, and definitely we will get some idea, and we will do some kind of photonic areas. And also water repellent beetle bags, and very nowadays aircraft and other materials, other areas, and people they are looking for hard and lightweight materials. So they have started token beaks, and it is very hard to broke, but it is very lightweight. Right? So the same question again, that whether we are making an attempt to mimic the wonder of nanoscience in nature. Definitely we will get a new ideas if we see and if we enjoy the natures that was given by the God. So when scientifically, if we are speaking with the nanoscale size, and the size of the nanoscale is all about, this is the pictures to realize the perception, okay, perception about the nanoscale materials. A sheet of, if you intersect you take an A4 sheet, single sheet, intersect into 1 lakh times, the one portion is called 1 nanometer thick. And also 1 nanometer is all about as your finger grows in 1 second. So can you imagine the size of nanoscales? Yeah, and also if the human hair is approximately 80,000 to 1 lakh nanometer wide, and if you take a single hair and intersect into 80,000 parts, and one part will be having an 1 nanometer scale. And also, if you take an 1 inch of size, and it contains 2.54 crores of nanometer in 1 inch. So just imagine the size of the nanoscales. So where we are dealing with, since the macro and micro, and nowadays we are talking about nano, and I do not know when the pico technologies will come and reach us. Right? The pico products will come and reach us. Definitely one day it will reach. Just a common picture, and wherever many times I hope you have seen these pictures. And this is just a comparison of football and the ratio of earth and football. So just to compare these two, and the ball is like when we compare the earth and football, and the football is the nanoscale. Similarly, the ratio of football and fullerene also. And just to think about how small it is. Yeah, we are dealing with the small materials. So what the nanotechnology difference from the conventional technology? So there are some technological advancements is also there. If we plant a tree, or if we plant a seed on that, and the seed is started growing, and if we watch daily and we cannot see the growth of the plant, right? So it is called the step growth polymerization process. Right? We used to call it as step growth polymerization process. Day by day, it started growing, and we cannot say that it is infinitely small changes will be there in the plant or tree or something like that. And that kind of architectures was developed for the living pattern. When it comes to when we are customizing within artificial materials, and there are two technologies, one is nanotechnology and conventional technologies. We need to understand this kind of technologies. So the conventional technology is nothing but the top-down approach, and the nanotechnology is the bottom-up approach. So what is exactly the conventional technology? Let me explain. And if you wanted to make it to prepare a toothpaste, and we will cut the tree, and we will make it an article what we want. And after that, the remaining materials has been converted into another product also. The beginning of the periods, the human beings started working in this model. So making small things from the big ones. So this is called the conventional technology. Now the nanotechnology is it is nothing but jigsaw puzzle and a children's game. I hope everyone has played these games. So there are many small pieces are there, and if we connect all these pieces of this zigzags, and definitely we will get some good articles. So what nanotechnology implies is that we will start from the small things, we will customize and we will do some manipulations in the atoms or molecules to develop a new materials. So making small things, making big things from the small ones, that is called nanotechnology. So why nanotechnology is most important? And that's my question. And there is only one point that is called when the size is reduced, not only the properties changes, and definitely there will be a change in the physical and chemical property, there is no doubt. So, and also if size reduces, definitely there will be a change in the reactivity also. So the surface volume ratios will increase. So if the size reduced, there will be a more surface area, and more the surface area, more will be the reactivity. So see, look at this picture, and if you intersect the single bar into one intersection, you will get the two pieces. Again, if you cut it into the two intersections, and you will get the 4, 8, and multiples of these. So, and also, just I would like to add this picture for the better understanding. Since the organizers from the Tirupati, and Tirupati means ultimately the geographical index tag is given for Laddu, and Tirupati means Laddu. Yeah. So if you take a Laddu, and we will be having some different sizes of booties. So if you have a Laddu, and if you crush it, and definitely you will get a booty. This is called booty. It covers more surface areas than this, and the small particles will have a more reactivity. Okay, let me continue, sir. Everything is fine?
Yes, sir. Yes, sir. Please continue.
Anyone, sir? Yeah. Thank you so much, sir. Yeah.
Yes.
So, and also one more perspective, that which dissolves faster in water, whether the granulated sugars or tightly packed sugar granules. So these two things are having a concept-oriented things, and if you have a granulated sugars and the tightly packed sugar granules, so which dissolves faster, can I request the participants to post your answers in the chat box. I quickly go through it, and then I will come back. And also, why it dissolves faster. That is also which dissolves faster in water is the question, and definitely you can predict it which one will dissolve faster. And what's my question to add on these things is why it is. Okay, let me quickly go through this chat box, and if anybody typed the answer. Yeah, Atlassian granulated sugar cause it has more surface area. Yeah, good, ma'am. Correct. I think the correct answer comes from the first end, and so I'll go to continue my presentation. Yes, obviously the answer is correct, and the granulated sugars, which is having more surface area than the tightly packed sugar granules. So now we can realize these things. If the surface area increases, there will be a more penetration with this solute or solvent or whatever the things. So similarly, these idea or concepts were majoritarily or maximum they have implemented in drug designing systems. They have used some previously. We will have some kind of big tablets, and nowadays they have giving a small tablets that will disperse into our human stomach, and it will spread over there, and it will penetrate into the veins and blood cells very faster and very easier. So. And what all the factors which affects by size reductions. So when we are reducing the size of the materials from the bulk one to nano, and definitely there will be a change in all the areas like thermal, optical, colors, surface reactivity, magnetic properties, photoreactivity, electrical properties, catalytic, biological properties, and many more properties will change. So what we are doing is only we are changing the size of the material, size of particles. And if we reduce the only one aspect, if we concentrate on one aspect, then definitely there will be an enhancement in many other properties also. So it is a gift for us. It minimized many of our works. So people, they are concentrating on nanotechnologies. So already what I have discussed is why nanotechnology. Size is very less. If size is less, and is more the reactivity, and if more the reactivity, definitely there will be a change in the properties also. So what is this? I would like to talk about this origin of properties. When we are talking about bulk, and there will be an unbound electrons, and the electron motions are not yet confined. But in this kind of nanoscale materials, after the size reduction, and during the size reduction process, and the electron motions becomes confined, and the quantization sets are in. So all we know that there is a if current flows in this copper wire, and there is a movement of electrons will be there. If the movement of electron is very faster, what will happen? Right. So similarly, in all the areas, so the magnetic properties, the soft magnetic materials and hard magnetic materials, both are there. And if it is a hard material, if we combine, if we manipulate into the original hard material, magnetic material into some other material, and that is called doping. And if we dope some kind of material into this, again, the entire property will get changed. So we can easily convert soft materials into hard material, or hard materials to soft material, whatever we want. So there is some change, and there is some kind of material innovations we can do our knowledge itself. So I would like to share one more with consolidating all these things what I have discussed, and there are some physical properties when the size is reduced from bulk to nano. One size, shape, specific surface area, aspect ratios, and agglomeration states and size distribution is also a major fact. Surface also, surface morphology will also change, structure, and including crystallinity and different structure, solubility, etc. Similarly, there will be a change in the chemical properties also. The structural formula and molecular formula will change. The composition of nanomaterials, the degree of purity is also changed. The base identity is also changed. If you take a zinc oxide, definitely there will be a Z structure, a structure, another structure like that in for titanium dioxide also. So surface chemistry, so more the surface area, definitely there will be an surface charge boundaries will be there in the kind of nanomaterials. So that will help us to work on different areas. So can we see nanostructures? Yes, there are many. The answer is obviously yes. There are many technologies has been arrived to see the nanostructures with the support of scanning electron microscope and the transmission electron microscopes. Here some of the pictures are given here. So generally people the nanotechnology or nanomaterials means people are working in different areas. Some of them are working with the metal oxide nanostructures or the metal nanoparticles like silver nanoparticle, gold nanoparticle, copper nanoparticle, etc. If you take a simple salt of source salts, and please don't think that I am teaching chemistry, and it is a very simple method to develop a nanoparticle. Everyone can prepare nanoparticles, and everyone can. There is no need to approach the scientific companies to buy some kind of nanoparticles for the desired size. And so just if you wanted to prepare silver nanoparticle, take in silver-based salts like silver nitrate, silver chlorides, or whatever the things, and do some kind of standard procedures under the reducing agents. With the support of reducing agent, definitely you will get a silver nanoparticle or gold nanoparticle, whatever the precursor you are taking. After that, if you exposed without adding the reducing agents, and just you are treating with an open environment, and that is the environment is consist of oxygens. If you calcine or if you are heating that particular material in the open environment, you will be getting in metal oxide nanoparticles. So metal oxide. So metal oxygen combinations, there will be a new binding. There are many semiconductors or comes under this category. And also we have heard about that's a carbon material. So it is a very simplest and simplest routes, and there are many technologies are there to develop a carbon material. One is the carbon nanotubes and multi-wall carbon nanotubes, and graphitic carbon, and graphene oxides and reduced graphene oxides, and graphitic carbon nitride is also in one more material based on the carbon. And also apart from that, there are very less people they are working in some categories like core shell nanoparticles, and that is the core is a nanoparticle. It is encapsulated with another nanoparticle that is called core shell nanoparticle. So core is one and shell is another nanoparticle. So the property, the transformation of electrons and the transformation of all the properties, which will be a combination of these two things, and one is encapsulated within another one. So the center core atom will play a big role, and definitely that will not be worse. And also some of the peoples, they are working in hybrid nanocomposites. So if you're taking some polymer based nanocomposites, they are taking polymers and they have taken the metal oxide nanoparticles what we have prepared earlier, and they are mixing it together. And after certain reaction conditions, they will get an hybrid nanocomposite materials. So these are all the classification of nanomaterials. All these kind of nanoparticles can be prepared with the support of some basic facilities, with available basic facilities. So while preparing these kind of nanomaterials, there are two methodologies were adopted universally to prepare nanoparticles. One is physical methods and another one is chemical methods. So I'm not telling physical methods are bad, but my point is to justify that if we are going for physical methods, you need you need more investments to buy some kind of equipments or instruments to carry out that kind of physical methods. Say for example, laser ablation method is a beautiful technique to produce nanoparticles. So there we need a laser HD or ND-OAG laser is required to produce nanoparticles. Or else, if you are moving for a high energy ball milling method, we need an ball millers, and chemical vapor deposition, we need an deposition units, and ED also we need an electro deposition unit to create nanoparticles on particular substrates. These are all some constraints in the physical methods. While we are taking and considering the physical methods, apart from the first technique, that is hydrothermal method, for this technique you need a hydrothermal autoclave unit. Other than that, it is very simple to develop a nanoparticle. These methods, there is sonochemical and the co-precipitation and electrospinning methods, and you need some electrospinning equipment, and salt gel and co-precipitation and sonochemical methods are the very feasible methods. If you have and round bottom flask or beaker and 2 glass rods, and we can on burette and pipette and some basic facilities we can develop any kind of nanoparticles which is available. So just since I am a chemist and just I would like to share some points how can we prepare some kind of nanomaterials. Just take in metal salts and add some capping agents, reducing agent, heat it, and finally you will get it a product. So these are all some of the famous reducing agents. That is depending upon our metal salts we can use it, and sodium citrates and sodium borohydrates and ascorbic acids and capping agents or thiols. These capping agents, the purpose of adding these capping agents to prevent agglomeration. So since it is very small and 2 or 3 will group each other and it forms an clusters, and 2 or 3 clusters combine each other and it forms an agglomeration. So to avoid that kind of agglomerations, we are adding some capping agents. So simple technique what we have developed through this Algel method, and this is a zinc oxide. Just see this kind of straight line procedures, and just take in zinc acetate, add aqueous ethanol, mix it and stir it for about 6 hours, and after that just sonicate for 2 to 3 minutes. More than that, it will break down the zinc oxygen bond also, and dried it for 150 degrees Celsius for an hour. You will be getting a zinc hydroxides. So zinc acetates gets converted into zinc hydroxides, and after that heat it to 500 degrees Celsius for 3 hours, and finally you will get the product A, that is called zinc oxide. So if you wanted to develop any binary mixtures or zinc doped ruthenium based combinations, or you wanted to prepare any composites, just take a zinc acetate and dissolve it in aqueous ethanol, add the material whatever you wanted to mix it, and just add it and mix these 3 substances, the zinc acetate and add the salts, metal salts, and dissolve it in the aqueous ethanol, and the same procedure to be followed, and finally you will get a different composition of materials. So this calcination temperature, it plays a big role, and the constant reaction time, this is also plays a big role in developing these 2 factors will affect the quality of the nanoparticle. We need to concentrate on these 2 areas also. So similarly, synthesis of carbon materials, people they will use if you purchase carbon, that is reduced graphene oxide in the market or Amazon or something, and 1 gram is cost around 4,000 rupees to 8,000 rupees. That is depending upon the purity, make, and other things. So there are some chemical routes. Easily we can prepare of around 6 grams for about 1,000 rupees. The 1,000 rupees raw materials can be used to prepare many grams of graphene oxides also. There are famous synthetic route that is called the Hummer's method. It is very useful, but the only one drawback is the duration of the reaction. That is called the time duration taken to develop a new RGO. That takes some 24 to 36 hours. So what are all the control factors if we are thinking about, if we wanted to prepare a good nanomaterial, what need to be concentrated? So one is the average size distribution is very, very important. So that is the reductant concentration and the stirring time and temperature. These 3 factors will affect the size of the particles and the size distribution. So if you are preparing 1 gram, if you take 1 particle and all the particles in the 1 gram are be in the uniform distribution of size. So one in 1 nanometer and 10 nanometers, and another set of particles are 20 nanometers. Another set of particles are 15 nanometers or plus. This will disturb the properties. So we need to stabilize the size. So in order to stabilize the size and the average particles, and we need to stabilize the solution. So it is started from the precursor to the product. So we need to concentrate all the areas. So simply I tell you, and chemical reactions are like cooking. If you wanted to prepare a fried chicken, and what we will do. So we need ingredients, and there are 3 phases. One is we need to prepare the ingredients, and we need to process, and finally we will taste it, right? So if you wanted to make the fried chicken, there are 3 ingredients are required. One is chicken, and second one is oil to fry the chicken, and third one is potato starch and salt or chili powders or etc. Right? So the most expensive area is 2. The one is the fried chicken, and another one is oil. Right? And third one is the some of the small amount of ingredients are required. So look at this picture. A is a chicken meat and B is an oil and AB is the fried chicken. So there are three factors are to be noted. First, the chicken are coated with an ingredient, and once if we need to ensure the oil is heated at the appropriate reach the appropriate temperature. After that, only we need to put it the chicken into that oil, and we need to get the good fried chicken. So if oil is not heated, we will not get the fried chicken, right? So the duration, how long we need to cook the chicken in the oil at the particular temperature. So this is the most important thing. If you take chicken and B is on oil, if both are in the right proportion, finally you will get AB, that is fried chicken, right? So if AB, after that, some of the chicken may be left out, or some of the oils may be left out. So we will. This is called byproducts A plus B. We will remove these byproducts. So if you take A and B, and if the right combination of A we have taken, and the excess of oil will be there, and we will remove the oil later. So the combination is we need to think about these areas. So if there are temperature is plays a major role, and cooking time plays a major role, and the concentration of the ingredients what we are coating over the chicken, that is also plays a role to deliver a good and delicious fried chicken. So technically, what I am calling as people they are calling as stoichiometric ratios, which means that the correct proportion of the ingredients level, and also temperature, that is degree Celsius of the oil, and the time duration, how long we need to cook. So these three factors, similarly, what chemical reactions are like cooking, what I said earlier, and similarly, if you concentrate on these three areas, you will get a good product during the reactions. So similarly, it's like an making rice and sambar. During the preparation of rice, we will add more water, and finally, we will not find any water. In sambar, we will add more water. The more water with the ingredients, finally, we will resultant product will also remain same. So there are two kind of reactions will happen. That is depending upon the reaction conditions. So while preparing that nanoparticles, and definitely we need to concentrate on how much amount of salt we need to take it, and how much of solvent, that is alcohols or some other things, we need to add to that particular. If any other reagents like salt or chili powders, and if any capping agents or reducing agents are required, and if yes, and how much amount we need to add, that all need to be predefined. And if we process clearly and process correctly, definitely we can produce and we can develop n number of materials. There are n number of materials. So this is the carbon materials which is developed from our laboratory, and so this is a graphene during the synthesis of graphene oxide, and the cost is I already shared this. I approached some scientific companies. They have said that I need 5 grams for my research purpose, and I requested. They have given the code for 35,000 to 40,000 rupees inclusive of all the taxes. So I thought to go back, and why not we will prepare these things, and it is the usual procedure. And they have made, I used the Hummer's method, and I have prepared graphene oxide. Later on, I was thinking about why we need to follow the Hummer's method. There are some other methods are also available. Why not we will create a new method? So I altered many changes during the reaction process, and we have developed one procedure, and that procedure, and we have made many trials with that, and finally we have got the good results of reduced graphene oxides with very low cost, and we are writing for the patent, and we are yet to submit the provisional submissions, and the final trial also has been completed, and we need to directly go in for patent publication. So these are all some of the results. I cannot reveal all the process because since it is going for a patent. So and just I will share a few pictures, and this is the graphene oxide sheets. which is observed. This was this graphene oxide was prepared from our modified method. And this is, have you seen this kind of pictures anywhere? Definitely, you have seen these things. This is the flexible paper-like structure was observed. Also, similarly, this is a metal nanoparticles which we have prepared, the sphere-like nanostructures was prepared in the laboratory. Also, always people we are using graphene oxide as an dopant or some other graphene oxide based materials, carbon based materials for many applications to produce lightweight materials. So, for example, now we are working with aluminum 6061 plus graphene oxide plus zinc oxide. We will get in composite materials, and we are going for corrosion technologies and other things also. While searching with the graphene oxides, the similar property we can develop from this graphitic carbon nitride. This is the structure, and the similar property here, the oxygen linkages is there, but in these things nitrogen is linkage is there. It is very simple to prepare. The same sheet-like structure will be appear for this graphitic carbon nitride also. So the synthesis procedure, this is very easy than the preparation of the graphene reduced RGO, reduced graphene oxide. So what I have observed is, so just to take an urea, right? So urea or don't go for thiourea, and it releases some sulfur-based gases. And taken urea and decompose it to 500 to 600 degrees Celsius for about 2 to 3 hours, and finally you will get an graphitic carbon nitride. It's a sheet-like structure was observed. So now we are working with these kind of structures to develop new materials. So what makes this? These are all what earlier I said is whether if you are an RGO or graphitic carbon nitride, both are available assets, right? So what if we wanted to manipulate or if we wanted to change any kind of innovations in the materials, graphene oxide and RGO and the graphite nitride, if we combine both of them, definitely there will be a change in the properties and application also. So the impact of manipulations. So we have taken the zinc oxide and ruthenium doped zinc oxides, and you have seen we have taken the dye solutions and we have added these two material into that. And after the certain reaction conditions, there is some degradation of dyes, and we have produced the hydrogen energy and production of during the production of hydrogen, and there is a degradation of hydrogen. See, look at this. So this is the raw UV visible spectroscopic technique. UV visible measure. See the peak, and if you take zinc oxide and after the photocatalytic reactions, and the concentration got reduced, and I have manipulated with the ruthenium ion into the zinc oxide. Finally, the properties. So the performance is higher in ruthenium zinc oxide and the zinc oxide, and then what plays a big role in these things. So when the photons are strikes on the surface of the zinc oxide, definitely the electron hole pair combinations, right? So the promotion of electrons from the ground state to the excited state, that is called the valence band to the conduction band. So these excited electrons are unstable. So this will help us as a radical, and this will help us to cleave this kind of dye solutions, and finally it produces some kind of hydrogen. So hydrogen production is very, it is an easier thing, but hydrogen storage in the energy sector it is very tough. So the manipulation, a small amount of ruthenium added to the zinc oxide, a small amount will play a big role in this property as well. So that is what I wanted to convey from this slide. So this is a very old image which was released by the BBC News by the year of 2004, and everywhere the two people are sitting and doing something, and around the area there are all the products in this they have used nanotechnologies. So what's my perception is after 10 years, not only my perception, it is a worldwide issue. After 10 years, we need to we need to go on all these type of problems, and there is no priority 1, 2, 3, 4, 5, and it is a cluster of problems we need to face after 10 years. One is energy, water, food. I hope that is nanotechnology will crack all these kind of all these kind of issues, problems in the future. So the impact of nanoscale research in the biomedical area too, the real-time applications, pharmacy, therapeutic drug, and DNA, RNA chips were developed, and information storage, and many other areas that have used nanoscale research. So what is my observation is I'm categorizing everybody is doing research. Many research articles are coming from the academic institutes, but many products are coming from the industry itself. So there are many ideas where that kind of ideas are going through. That is the question. That is the question arises. So I am classifying by two types. One is academic R&D, and the another one is an industrial R&D. And in academic R&D, we are identifying the problem statements, and we are executing all these things, and we are going for publication. And a few of the academic people are going for a patent. And even though if it is patent or granted, and it was not commercialized, what our industrial R&Ds are doing, and they are identifying the same problem, and they are also executing these things. They are not going for publications; they are directly going for a patent, and they are commercializing that particular patent. And the product development is, and after the product development, it is available in the market. So, what kind of transformation is required? So we need to bridge the academic and the industrial relationships. So these two will help us. That is, in the industry, or as a faculty member is doing something, and that idea definitely will come to the reality if we walk through the industrial R&D. Okay, right. So, and also in many engineering areas, and if we combine the engineering peoples with the science domains like physics or chemistry, like that, and we can do many material innovations in that, and we can do wonders. So there are plenty of opportunities in the new product development, and also if we combine the interdisciplinary approaches, and if you start working with these interdisciplinary areas, definitely we can do many things. And if we done any kind of identified any kind of problems which is needed for real time, and definitely we will approach the industry for the commercialization and the product development. So there are plenty of scopes are also available in the field of nanomaterials. If you type nano in Science Direct, interestingly, you will find 4,54,000 results. So it combinations of all the things. And similarly, if you type nanoparticles for engineering applications, if you are going for a broader way, and definitely you see the results, it reduces to 1,37,037 or 38,000 results. And if you go for a nanoparticle for biomedical applications, the results are very less. So there are some scopes in biomedical applications also. So if you are preparing a material for any specified like a heat transfer or catalysis applications or semiconductor applications or magnetic applications, and prepare it and do it whatever the things what we need to do, and after that we will send the samples to the biotechnologist to carry out some other properties, and this will produce us one more paper also. So this way we can extend our research collaborations in the biomedical applications. There are wide scope areas are there. And also there the biomedical applications, yeah, I know many people they are working in the polymeric. These are all the possible collaborations in the biomedical application areas. If you are working with the hybrid nanostructure materials, that is polymeric nanocomposite materials, and these can be used in nano capsules, nano gels, nano fibers, etc. So drug designing, drug delivery, gene therapy. So the only one thing is we need to identify the person who is working in the biology these areas, and we will send the samples to them, and they will do some basic analysis, and based on that we will go ahead. So many of them are working with the magnetic materials also. This is the wonderful material. There are plenty of scopes are available in the magnetic material areas. That is, we can combine both the energy storage sector as well as bioengineering medicine separation. So hybrid composites also we have many other opportunities in drug designing, and also we can develop many develop very lightweight materials and high strength materials in the field of energy storage or energy storage containers. So carbon-based materials also, as we have discussed, graphene and graphene oxides and graphitic carbon nitrates can also be used in the biological applications. So what they now the nanotechnology we have imported from other countries, and now the COVID situations has created many opportunities to produce new products as an in-house productions. So IIT Delhi made an antiviral nano coating for medical mask N95 respirators. So this was funded by the DST. It was the article I have gone through and one of So, and also there are many coatings, there are many innovations in the paint industry also. They will add some kind of nanomaterials into the paint and they will coat it, and it is an antibacterial and antibiocidal applications, and definitely there will be no fungus. So perception matters. So can you please see how many phases are there? So why I am telling this brainstorming is we need to think it in the different way. So we need to think about the natures, and we have plenty of opportunities are there. And we will search the literatures to identify the scopes. And if we see nature, there itself the number of scopes are there, and uniqueness is most important. And we need to go with the desired application-based things. There are two kind of researches are going on. The one is they will identify the problem and they will execute it. Remaining, they will execute it. They will fit into the where it need to be used. So these kind of two perspective researches are going there, and find out which is good and which is not good. So perception matters. And also similarly, how many horses have you seen? Yes. Yeah, thank you so much for the patient listening. And once again, thank you for the organizers for giving me this opportunity. I am ready to answer. This is the end of my presentation. I'll be happy to answer the queries that you have. Yes, sir. Hand it over to you, sir.
Thank you, sir. We are having a few questions in the chat box also.
Yeah, let me go through it.
Actually, it is Sunil Kumar Saudri. He has started, sir. The first question is, how nano powder can be dispersed in liquid so that no settling can be taken place? Shall I read once, sir? Sir, shall I read once again, sir?
Sir, yes, sir. Please, I'm sorry.
Okay.
I didn't get the audio properly. I'm sorry.
Okay.
Yeah.
Okay. This is from Professor Sunil Kumar Saudri. How nano powder can be dispersed in liquid so that no settling can be taken place?
Yeah. When we are discussing about the disbursement, because we are preparing nanoparticles at high temperature, usually the solubility factor is a very big problem. Due to the, if we dispersed, the suitable solvents may be selected, and also the proper sonication to be done, because due to the Brownian motion, nanoparticles will automatically get settled down. The purpose of the application, where they need to be used and what kind of nanomaterials are to be used, that to be defined further. And if we want, if we wanted to prepare, some of the people are working in nanofluids, so they will disperse with the polymers, polyethylene glycol. They will add some kind of nanoparticles, and they will disperse it, and they will use it for heat transfer applications also. So if you really want a nanoparticle in the liquid phase, go to that particular gel-based nano gel-based preparations. If you have prepared a powder and then you wanted to make it a gel, it is quite complicated.
Thank you, sir. Another question from Professor Sunil Kumar. Agglomeration is a big issue in nanotechnology. How it can be get rid of that?
Yes. Sir, yes, I also agree with this point because we are dealing with a very small size of the particles, and the only one thing is the stabilization of the nanoparticle is most important. Say, for example, if we are preparing any nanoparticles, and we can go for ultrasonication techniques. So there you can there the ultrasonic waves can be targeted into our samples, and this will disperse the particle. This will prevent agglomeration. And also, you can use capping agents, surfactants, that during the preparation that will help you to reduce the agglomerations.
Thank you, sir. This is another question from Professor Ravi Kumar.
Yes,
First
sir.
question: what is better nanofluid for heat transfer application? Second question, sir. I will continue, sir. Suggest the better pair of hybrid nanofluid for the same purpose.
So, sir, I will repeat the question whether I have understood correctly.
Yes, sir. First,
What is the right material for heat transfer application?
yes, sir. What is better nanofluid for heat transfer application? This is first question.
Okay. Sir, actually, I have just worked in a few areas with the heat transfer applications in the nanofluid. People, they are using the polyethylene glycol with, you can add a zinc oxide, titanium dioxide, copper oxide, magnesium oxides, even the graphene oxides are also be used for the heat transfer application. The only one thing we need to concentrate is the proportions. How much amount of the zinc oxide or titanium oxide to be added to this polymers. That is most important thing, because if you add 1 gram in 100 gram of polyethylene glycol, this will give some other results. And if you add 5 grams, and definitely the proportions is also plays a matter. And also there are many studies are going on this. There is no specific applications, the specific materials. This is very suitable for these things. And that I'm sorry, sir, I couldn't predict it.
Okay, sir. Sir, second question, sir. Suggest the better pair of hybrid nanofluid for same purpose.
Yeah, the purpose of selecting polyethylene glycol, the one is the flow and the movement, and you can go for polyvinyl alcohol also will give good results, and glycerol based combinations are also giving good results with a similar kind of metal oxide nanoparticles, because it is having high stability in the polymer mixing. I think you can go for polyvinyl alcohols and glycerin based, sir, and in the cell for this side and nanomaterials, and you can go for metal oxide nanoparticles. Both the combinations will give good results.
Thank you, sir. This is another question from Professor Sarath. Can you give more light on core shell nanoparticles and some examples for hybrid nanoparticles?
Yeah, for about hybrid nanocomposites is nothing but it is not a pure nanomaterial, and that is the silver nanoparticle and the copper, like that. And it is a combination of organic polymers blended with the nanoparticles, and both will link each other. And the linkages between the nanoparticle and the polymeric nanostructures or the blending mode, and this will be very strong in the due to the electrostatic interaction. And finally, we will get the product. This is called the hybrid nanocomposites. When it comes to core shell nanoparticles, if you are having two set of nanoparticles, one is core, one will act as in core, and another one will act as an shell, and one will be encapsulated within another one. So there are nickel silicon core shell nanoparticles are there, and iron silver core shell nanoparticles are there. So during the synthesis procedure, we can make an alternations also. And also, if you wanted to go for core shell nanoparticles, and there is a different procedure to be adopted. And if you wanted to prepare metal oxide, there we need to go for another.
Sir, thank you, sir. Now I request our participants, please unmute yourself. You can ask question directly to our resource person. or you can type your question in chat box. We will ask on behalf of you.
Hello.
Yes, sir. Please, sir. Please.
Can you hear me, sir?
Yes, sir. Audible, sir. Please continue, sir.
Good afternoon, sir. It was a wonderful presentation. We got so many inputs regarding.
Sir, sorry, sir. Slightly louder, please. Sir.
Hello, sir. Can you hear me?
Yes. Yes, sir. Yes, sir. Please. Sir.
We got very much useful inputs from this presentation. So my query about core shell nanoparticles, sir. Can you please explain how it will be prepared? What do you mean core? Whether we'll be encapsulating the core nanoparticles first, then upon which we'll be coating this other nanoparticles, sir? Whether that is the right way?
Yeah. Sir, regarding the core shell nanoparticle, it's an interesting thing. And first, what's my suggestion for your better understanding? Say, for example, if you are preparing a core shell nanoparticle, first you will dispose the materials into the. If you are preparing a nanoparticle, just imagine, and take a first core material first, and then you need to encapsulate which one to be encapsulated. That material ought to be processed separately, and then we need to add it here, and you need to encapsulate properly. That you need to ensure through the stirring and the encapsulation. There are some blending modes are there to prepare core shell nanoparticles. So there are many literatures are also available, because I didn't prepare. There are certain procedures are there to prepare core shell nanoparticles. I too used some procedures to prepare nickel copper core shell nanoparticles and iron zinc core shell nanoparticles we have prepared with the support of some capping agents and surfactants. And right now I don't have that paper with me, and I will share the link to the organizers, and definitely you will take it, sir.
Please, sir. One more thing, sir. What is the possible application for this core shell nanoparticles? Can you throw light on that?
Sir, there are many applications in the electronic industries. It is working, sir, and also biomedical applications. It is used, sir. And also these nowadays the people, they are incorporating the heat transfer also, sir. You are belongs to which department, sir? I'm sorry.
Sir, I'm from mechanical thermal engineering department, sir. Thermal science.
Thermal engineering. Okay. So you can use it for heat storage applications and PCM materials. So phase changing materials, there you will use calcium carbonate and other things, sir. So there you can add some kind of materials. It is the best heat transfer material as well as biomedical applications also.
Sir, actually, I am working with phase change materials only. My research is thermal energy storage by using phase change materials.
So okay, yeah.
My next
I had a collaboration with my departments, and we did some small works in the field of phase changing.
Yes, sir. So I'm working with encapsulation of phase change materials, sir, by using polymeric shells.
Super.
So can you please explain tell about some methods which are going to be effective in encapsulating the PCM, so that I can have more content of core. Shell should be there, but it is because when I'm trying, shell is more quantity, core is very less quantity. Can you please?
The blending should be very proper, sir. Otherwise, the two nanoparticles will get separated and it forms a secondary phases. Like the core nanoparticles will form a single separate nanoparticle, and this will also get separated. And we need to encapsulate the blending procedures to be followed, sir. So I will share some of the literatures and the procedures for you. Right, sir? A set of questions related to the core shell nanoparticle. And definitely you can encapsulate with PCM also.
Sure, sir. Can you please share your mail ID, sir? I will be in touch with you.
Yeah. I will send my mail ID in the chat box. Okay. Just send an email what purpose you need and what kind of application you are working for, and definitely I will reply for. I have some materials also. Yeah.
Yes, sir. Thank you very much, sir. Wonderful session, sir.
Yeah. Thank you.
Sir, our resource person mail ID is available in chat box, sir. Please, you can contact, sir. Thank you, sir. Thank you. Sir, one more question from Professor Kuldeep Kumar, sir. In many places, I have seen a word quantum confinement. What is this in nanoscience and nanotechnology?
So I am not that much clear in that particular quantum confinement, sir. But what my observation is, the motion of electrons, that is, the transfer possibilities may be increased. Where the material which is having the more number of electron transfers and the excitation possibilities, then they will call it as a confinement in the quantum scale. So I'm not very much clear in that quantum confinement, Professor Kuldeep Kumar sir, and really sorry for that. And let me take and then let you know. Yeah, please.
Thank you, sir. Now I request our participants, please unmute yourself and you can ask questions directly to our resource persons. Sir, is there anybody, sir? Please proceed, sir. You can unmute and you can ask your questions, sir, directly to our resource person. Sir, resource person, sir.
Sir, yes, sir.
Sir, I will go with vote of thanks, sir. It seems no question. It seems.
Yeah. Thank you.
Thank you very much for your excellent presentation, sir. It is really very informative session, sir. You have started with research scope and opportunities, moving towards the future technology, nanotechnology in interdisciplinary disciplines, and nanoscience and nanotechnology, making big things with the small stuff. Nanotechnology in ancient times, natural nanomaterials, and nanotechnology with conventional technology. Why nano surface volume ratio we are using, and factors affected by size reduction and origin of properties and physical properties. Can we see nanostructures? Yes, we have seen, and classification of nanomaterials, synthesis of nanomaterial like the physical method and the chemical method, and what are the control factors, temperature, time, etc., and the synthesis of carbon materials, them results, and the impact of manipulation, impact of nanotechnology, and finally nanomaterials for biomedical applications. It is really very detailed and informative session, sir. Thank you very much.
That was thank you so much, sir. That was a really an amazing set of participants, and I would like to record my gratitude here in this virtual forum for having given me an opportunity to be the resource person for today's session. And I hope this would have been useful for you all, and I hope I made it your time worthy. And thank you all once again. And since I have made my presentations from the most fundamental aspects, and also some very basic things are also being explained. And thank you so much for once again. Thank you.
Thank you, sir. We are honored, sir. Now I request participants. Our today's session is over. Our tomorrow session is a nanotechnology lead acid energy storages. Time is 10 a.m. to 12 noon. It will be given by Mr. Sridhar, Senior Engineer R&D, Amarraja Batteries, Tirupati. And our afternoon session, the relevance of indentation, nano and micro in material research from Dr. A. Kumarasamy, Professor and Head Department of Technology, Management Materials and Defense Institute of Advanced Technology from Pune. I request all the participants please join tomorrow's session 9:45 a.m. I request once again thanking you. Today's session it is over. Thanking you all.